All right, I'm gonna speed run this because this is my second time filming it. All right, so here's some practice problems to help you out for the worksheet that you're working on right now. Let's go through number one. All right, a crane at a construction site uses 4,900 newtons of force to lift a concrete beam to the top of a building that is 30 meters high. Calculate the work. Okay, so for our variables, we're gonna write down what we're given. We know force is equal to 4,900 newtons, and then we know that our distance is equal to 30 meters. Now, work has two equations, but because I'm given force and distance, I know I'm gonna use work is equal to force times distance times cosine theta. Now remember, this theta right here is your angle. And if you're not given an angle, which we're not here, our angle is gonna be 0. So let's plug in what we know. Work is equal to 4,900 times 30 times cosine of 0. And that gives us an answer of 1,900 times, what was the other number? 30 times cosine of 0. That gives us an answer of 147,000 joules. Remember joules because we're solving for work. Again, very simple. Look at what you're given, and that tells you which equation you should use. All right, let's go to the next one. Perfect. Let's read the problem. The car accelerates from 30 meters per second, or 20 meters per second, to 30 over a distance of 500 meters. If the mass of the car is 1,500 kg, calculate the work. All right, perfect. Let's look at what we're given. We're given a initial velocity of 20 meters per second, and then the car speeds up to 30. So that's my final velocity. We know our distance of 500 meters. And we know our mass of the car of 1,500 kg. So remember, we are solving for work. And because we have two velocities, we're going to use our equation of work is equal to KE final minus KE initial. All right, and we know I'm going to use this one because I have two velocities, and that's the key giveaway. All right, so let's plug in what we know. Real quick, if you don't know how to solve for kinetic energy, right here, 0.5 times mass times velocity squared. There's our equation. So let's go ahead and solve for KEF, our final velocity, our final kinetic energy. 0.5 times the mass, which is 1,500, times the final velocity, which is 30 squared. Okay, that's going to give us our answer, 0.5 times 1,500 times 30 squared. That's going to give us 675,000 joules. Let's do the next one. For KEI, that's going to be 0.5 times 1,500 times, now I'm going to use my initial velocity of 20 squared. So 0.5 times 1,500 times 20 squared. You should get an answer of 300,000 joules. Now what you're going to do is you're going to take this number and subtract it from this number, your final minus your initial right here. So 675,000 minus 300,000. And we should get our answer of 375,000. We're solving for work, so that is joules. Again, I know I'm using this equation here because I'm given two velocities. That's the key giveaway. All right, let's move on to the next one. All right, Jake is participating in a powerlifting competition. He lifts a barbell weighing 200 kilograms to a height of 1.5 meters in 2 seconds. Calculate the power. So I'm solving for power. Let's write down what we're given. We have our mass of 200 kg. We have a distance of 1.5 meters, and we have a time of 2 seconds. Now our equation for power is pretty simple. Power is equal to work divided by time. But if we look at what we're given, notice we are not given work. So we have to solve for it. Work is equal to force times distance times cosine theta. Now, if we look at what we're given here, we know our distance. We're not given an angle, so we know that our cosine theta is 0. But we are not given force. So now we got to take it an extra step. We got to solve for force, which is equal to mass times acceleration. Now, we are given a mass, but we are not given acceleration. But this is happening on Earth, so the acceleration due to gravity is 9.8. This is our acceleration. So let's do step 1 and solve for force. Force is equal to our mass, 200 kilograms, times our acceleration due to gravity, which is 9.8. Let's go ahead and solve for that. 200 times 9.8. And we are given 1,960 newtons. So I solved for force. Now we can solve for work. Force is 1960 times our distance, which is 1.5, that's given to us, times cosine 0. Let's plug that into our calculator. 1960 times 1.5 times cosine of 0. And we get 2940. We're solving for work, so that is joules. Now, the last step, we solve for force, we solve for work. Now, let's solve for power. Power is equal to our work, which is 2940, divided by our time. Remember, our time is given to us 2 seconds. Let's plug that in. 2940 divided by 2. And we should get our answer of 1470 watts, because we are solving for power. This is a lot of steps, but you will have a question like this on the quiz and on the exam, so make sure that we are paying attention. Again, step 1 is solve for force. Step 2 is solve for work. Then we can solve for power. Okay, takes a little bit of time, but just follow these steps and you have a video here to look back to. All right, let's go to the next one. Set that up. There we go. Sarah's competing, is a competitive powerlifter who completes 1,176 joules of work to complete a power clean. She completes this lift in 3 seconds. Calculate the, power. All right, so write down what we're given in our variables. We know work is equal to 1,176 joules, and we know that our time is 3 seconds. We are solving for power, and we know power is equal to work divided by time. This one's very easy. Let's plug it in. Power is equal to 1,176 divided by 3. Let's get our answer. 76 divided by 3. And we get our answer of 392 watts, because we are solving for power. Really easy, really straightforward. All right, let's go to the last one. All right. During the training session, Mark squats 200 kg to a height of 0.6 meters in 4 seconds. Determine the power. Perfect. Let's write down what we're given. Mass is equal to 200. Distance is equal to 0.6. And our time is equal to 4 seconds. Okay, the equation, because we are solving for power, is P equals W over T. Okay, now if we're looking at what we're given, we are not given power, we are given time. So, we're not given work, but we are given time. So let's solve for work. Work is equal to F times distance times cosine theta. We're not given an angle, so we know our angle is 0. We're not given force here, so we got to solve for force. Mass times acceleration. And remember, acceleration due to gravity is 9.8. So let's go ahead and solve for force. Mass is 200 times 9.8. We get our answer of 1960 newtons. So here's our force. Step 2, solve for work. Work is equal to 1960 times our distance, which is given to us, 0.6 times cosine of 0. 1960 times 0.6 times cosine of 0. We get our answer of 1176 joules. That's our work. Now step 3, solve for power. Solve for power. Power is equal to work, 1176, divided by our time. Our time is given to us over here, 4. So let's plug that in. 1176 divided by 4. And we get 294. And we're solving for power, so it's watts. Again, just like last time, a lot of steps, but nothing too complicated. Okay. Now you're going to use these 5 practice problems to help you answer the questions you have in front of you. Okay, refer back to this video if you do need any help.